we are going to start or not start. We have already started class 7th NCERT and we will continue that. I think you have already learned a lot from class 6 NCERT, more than what you were expecting. And today's class is going to be quite something. You will be surprised and shocked that how much you don't know and how much you should know. So, oh, let me first attach my phone. Sound would be better now. आवाज अच्छी आ रही है अब? Good afternoon, everyone. Shankar, Krishna, Mohi, Sonali, and your name is very difficult for me to pronounce. Daryang. It's hard. Okay, I hope I'm not audible. I should be. Yeah, I'm audible. आवाज सबको अच्छी आ रही है ना? So, how many of you are from science background? How many of you read science till class 12th? Hands. My father. ये क्या है रजत भाई? Okay, so today is going to be your test. I want to see how many of you know how much science. So be ready. Today's class is going to be a ride, quite something. देखना कितना किसको आता है. चलो स्टार्ट करते हैं. हाँ, इंजीनियरिंग वालों का और अच्छा टेस्ट होगा आज. So chapter 2 we had done, if I remember correctly, and all of you can lower your hands now. And we are going to start chapter number 3. विनय कुछ पूछना चाहते हो? नहीं, ठीक. So our changing earth. In the last class, we were talking about the movement of lithospheric plates, and I had given you an example of a football, and let's suppose like the patches of football, there are lithospheric plates. Unlike the patches of football, these are not fixed, but they float, they move, and the cause of their movement is the movement of molten lava inside the earth, which caused the circular movement. A very good example has been given by the NCERT thought experiment. If you boil the water, and most of you have done the boil the water, you know that the warm water rises up, comes to the surface, and then sinks down. Similarly, this happens in both parts, and that's why if something is kept here, it will start moving towards this with the water, and if something is kept here, it will start moving towards this. And if this is the Earth's plate, there will be a fracture created. One part will be moving towards this, other part will be moving towards this. This is how the lithospheric plate movement happens. Now we we're reading about the forces which cause the earth movement, and these are endogenic forces and exogenic forces. Now, endo means something which is interior. Exo means something which is outside. So the forces, genic means originated. The forces which are originating from inside the earth are endogenic forces. In these endogenic forces, there are two kind of forces: the sudden forces and the diastrophic forces. These sudden forces, earthquake, volcano, landslide, which does not give you much warning, they will just happen. Santoshi is saying I'm not audible properly. Is it the case with everyone? So we check your network, and if if it's not audible for you, what you can do is, you see on the top of the screen, you will see live on YouTube. From there, if you will click, you will get a copy streaming link or view stream on YouTube. So if you will click on view stream on YouTube, you can go to YouTube. You can lower the resolution, and probably it will be better there. If any of you is on lower network, you can go and watch on YouTube. So हाँ, तो कहाँ थे हम? Endogenic forces, sudden forces and diastrophic forces. Sudden forces are earthquake, volcano, and landslide. They don't give you much warning, they will come suddenly. Diastrophic forces are mountain building forces. These forces can happen on a long process, slow movement, can be sudden as well, but generally they are slowly happening. Like we read about faults and folds. So it will not happen like something. Some Himalayas will be created in one day. Himalayas will be created after thousands of years of continuous movement of the plates. We will read about that in greater detail. So the slower ones are diastrophic forces, continuously happening. And then we have erosional and depositional forces. So erosion and deposition will happen because of a river or water, wind, that is air, sea waves, again water, and glaciers. So all these things can lead to erosion as well as deposition. We will read about that. Now come to the discussion of volcanoes. We have already discussed about volcanoes. A volcano is a very good definition of volcano. Volcano is a vent or an opening in the earth's crust through which molten materials erupt suddenly. बहुत अच्छा definition है. All of you know about volcano, but if I ask you to define volcano, I don't think any of you will be able to. मैं भी नहीं कर पाता, इसलिए मुझे पता है कि तुम भी नहीं कर पाओगे. So memorize this definition. Volcano is an opening in the earth crust through which molten materials erupt suddenly. Will be very handy in our UPSC syllabus. We have to specifically read this topic. Now, we have read about different parts of volcano already. So there is this magma chamber. From here, it will go up, come from different vents, the openings. From the main vent, you will get gases and ash coming out, and it creates a crater here. What will happen? There will be a mountain. It will, with the explosion, it will collapse. This will collapse and fall down into the vent. So it will lead to the formation of crater. We will discuss about different types of volcanoes later in higher classes. For just now, itna yaad rakho. Again, about earthquakes, we will read in greater detail. But two things you need to memorize, very, very important. I always forget this. I've made this mistake and I keep making this mistake. And I know it's a little bit confusing. See, earthquakes will originate somewhere inside the earth. And these are the vibrations. क्या कह सकते हैं? Vibrations happening because of the lithospheric plate movements are called earthquakes. क्या definition लिख सकते हो? Vibrations happening because of lithospheric plate movement are earthquakes. Now, the place inside the earth where earthquake is originating is known as focus. ये क्या हो रहा है? सब कुछ यहाँ पे आके focused हो रहा है. Like, think about a beam of light focusing at one place. So this is focus. And from here, the waves, the vibrations will start moving, traveling towards the Earth's surface. And the point where we first notice the vibration is called epicenter. Okay, the place on the surface above the focus is called as epicenter. So at epicenter, you will first notice that there is a earthquake. Is it okay? Focus होगा अंदर और epicenter होगा बाहर. So the greatest damage usually happens at the epicenter because here the vibrations will be very strong. And as it moves away from this, it gets the strength of the earthquake gets lesser and lesser. We have to read about P waves, S waves, and L waves. About this, we will read in great detail. बहुत detail से पढ़ना है, but we will do that in class 11th. Now, how to know about earthquakes? Earthquakes are very sudden, but there are many methods to predict earthquakes. Many people, especially local tribal people, can predict about earthquake by studying the animal behavior. The fish in the ponds get agitated. The snakes come on the surface. The dogs will start barking because they sense the vibration much earlier than we can. So they give us a slightly थोड़े देर का 10-5 सेकंड या 30 सेकंड 1 मिनट का वार्निंग दे सकते हैं वो. Then we have seismograph. Seismograph measures the magnitude of the earthquake on a Richter scale. Magnitude of the earthquake varies between 2 to 7 or 8. Major classification 7 या उससे ज़्यादा हो सकता है. Now there is one more scale which measures the intensity of the earthquake. Can you name the scale on which we measure the intensity of the earthquake? Anyone? किसी ने रट्टा मारा है? There is a scale called Mercalli scale. On that we measure the intensity of the earthquake. Now, what's the difference between the intensity and the magnitude of the earthquake? See, magnitude of the earthquake will tell you that how large the vibration was, how strong the earthquake was. But if this earthquake will come in USA, Let's suppose a 6 magnitude ka earthquake is coming in USA. Now in USA, buildings are more strong. They are made keeping in mind. Let's suppose they are made keeping in mind the earthquake prone majors. So the damage here will be less. But if the same kind of earthquake have, we already had such situations when the earthquake hit in South America, Latin American countries, they were not that prepared. The infrastructure was not good. Even Nepal, when the earthquake came in Nepal, it was not that big, but they were not prepared. Their infrastructure was very poor. So that lead to more deaths, more casualties. The intensity actually measures the causality, how much damage the earthquake has done, and it varies from place to place. The Mercalli scale will measure the intensity, the Richter scale will measure magnitude, and the machine is called seismograph. Now, major landforms, थोड़ा landforms के बारे में पढ़ते हैं. There is this two very good definitions: weathering and erosion. Weathering is breaking of the rocks on Earth's surface, and erosion is withering away of the landscape by different agents like water, wind, and ice. Withering में क्या हो रहा है? दोनों, the process is same. Both are the process of breaking of the larger substance into smaller particles. The difference is the difference is that in weathering, the particle will break down and will remain where it is. जैसे कि let's think about a mountain. So on the mountain's footholds, the weathering is happening, and after the weathering, the rock turns into soil and it remains there. Weathering. Erosion is wearing away of the landscape by different agents. Erosion में क्या हो रहा है? The mountain is there, the water is flowing, it will erode the surface, it will eat up into the mountains, it will break the larger molecules into smaller, and or larger particles into smaller particles and carry it away with itself. It will not leave it there, it will carry it away. So erosion will happen at the place on the earth surface. Weathering will carry away, oh sorry, erosion will carry away the landscape. Landscape, they were, who's asking? Devasis is asking landscape. Landscape is everything that you can see on the land. The mountains, the plateaus, the soil is landscape. Difference समझ में आया? Weathering and erosion में. Is it very clear? Now, erosion can happen because of different factors. Erosion can happen because of water, can happen because of air. We will read all these. The first is the work of a river. How water leads to weathering or erosion. What will happen? See, Earth's surface, Earth's crust that we see is not homogeneous. It's not like everywhere you will find same kind of soil or rock. In the same place, you can find the softer layer, and at some place you will find the harder rock. Now, here you can see in this image, if you will concentrate, what the river is doing is that it will erode the soft rock. It will soft rock undercut by the power of the water, but it will not be able to cut the hard rock. तो एक ऐसा सिचुएशन है, पहले कैसे रहा होगा, ऐसा होगा. If you want to imagine this, imagine it like this. This is a flat surface, or not flat. This would be a slightly inclined surface on which the river is flowing. Normal river is flowing. Now, the top layer of this is a soft rock. मानो एक soft rock ऐसा बना हुआ है. And below this, you have hard rock. So what river will do, that it will erode the soft rock. Now, let's suppose that this hard rock ends here, and here you have soft rock. So what the river water will do, it will not be able to erode here, but it will start slowly eroding here. And it will be a year-long process, hundreds, thousands of years. It will slowly erode, and it will keep flowing like this. And when it will have eroded all this part, it will start falling deep down, because all this soft rock has been eroded. See how the waterfall is being created. Imagine कर पा रहे हो कैसे waterfall बन रहा है. The soft rock is eroded and the hard rock cannot be eroded by the water. So if you will find a suitable landform, it will make the waterfall. Is it clear to all? Now, meanders. See, this we will read in great detail again in class 11th, but थोड़ा सा देख लेते हैं. देखो, this is a river and this is the flood plain. From this area to this area will be called flood plains. Why flood plains? Because when the river will be overflowing, when there will be a lot of water in this, the water can overflow up to this region, but it will not cross this region because this region is too high. So these are called levees. Now this can be 5 kilometers, 10 kilometers, 50 kilometers long. So floodplains and levees. Now see what's happening here. The river is flowing. It's imagine it like this. Let's suppose this is Himalayas, and from here water has started to flow. The Ganga is originating. In the initial phase, there will be a steep slope. The slope will be very steep and the river will be flowing at a very high speed. It will be eroding because it has a lot of force with it. So it will be eroding whatever comes into its way. It will break the rocks and will carry all the rocks with it. Very high speed. Slowly it will come down to plains. So basically, if we talk about Ganga near Haridwar, it comes down from rivers to plains. And gradually, the slope will start decreasing and decreasing and decreasing. And when it will reach up to Ganga and all, the slope would have been almost completely flat. Now, when till the point Ganga has force, it will be flowing in a straight direction. जो आएगा उसको उड़ा देंगे. लेकिन you might have seen if you uh, drop water on a very flat surface, you have dropped some with the, and if you have noticed, if the surface is flat, water doesn't know where to go, so it will move like किधर भी जा रहे हैं टेढ़ा मेढ़ा होके घूम रहा है उसको पता नहीं किधर जाना है. But if there is a slope, it will take that direction and flow into that direction straight. Same thing will start happening to the river when it will come into the plains, and it will move into the directions where it will find slightest slope or सॉफ्ट रॉक्स. जहां भी इजीली इरोड कर पाएगा उधर मूव कर जाएगा. तो देखो यहाँ से इट विल टर्न टुवर्ड्स दिस, देन इट विल टर्न टुवर्ड दिस, एंड ये नागिन डांस करना शुरू कर देगा. दिस इज कॉल्ड meanders. The twist and the turns forming large bends are known as meanders. And it will be doing continuous erosion and deposition along the sides of the meanders. Continuous erosion and deposition hoga. We will see how the erosion and deposition happens, where the erosion will happen, where the deposition will happen. We will see in class 11. So I'm not going into that as of now. What will happen, that is very specific landform or feature which is made as oxbow lakes. Let's suppose this is our river meandering like this. What will happen, that because of erosion or deposition, at some time, like let's suppose river is meandering like this, but after some time it will stop meandering this much. The meanders will become smaller because of erosion or depositional factors. ज़्यादा पानी आ गया, slope change हो गया. So it will not meander like this, and a part of river will be cut, and that will exist there like a oxbow lake. या हमेशा हॉर्स शू के टाइप में या हॉर्स के सूल के टाइप में, ऑक्सबो के टाइप में it will exist there. It's called Oxbow Lake. We'll read about it in a little bit more detail later in class 11. Now, distributaries. As we said, when the rivers will come to the flood plains or in the plains, it will start dividing into different streams because it has no more force. It doesn't has the force to carry on in a straight line. So whatever stream will find whatever suitable route for it, it will just take that path and continue flowing. So these are called distributaries. Opposite to it, in the initial phase, many rivers will come and meet into the river. They will drop their waters and they are called tributaries. So distributaries and tributaries. And the later part, they will create delta, the triangle-like shapes we have already discussed. Now, how sea waves will lead to erosion and deposition. See, there are three features that we need to know about: caves, arches, and stack. This sea wave is continuously hitting this mountain. By continuously hitting it, it will create a cave. Now suppose that it's the same thing is happening for thousands of years. So the cave will become an arch because the water will penetrate the rock throughout. छेद कर देगा, इस पार से उस पार चले जाओगे. So the shape that you can see will look like a arch because there is a tunnel in between. So this will be your mountain, and a tunnel will be created like this, and a R-shaped structure will emerge. Again, after more 100 or 500 years, what will happen that it will slowly keep on eroding, and it will completely erode this part. What will happen? Only this part will be standing, and this part is called stack. Caves से start होगा और erosion होगा तो sea arch बनेगा and stack will be the last. So these are the erosional features of coastal landforms. Now there is also a sea cliff. Steep rocky coast rising almost vertically above the sea water is known as sea cliff. At some places, you will see that there is the mountain, and from the bottom it you might have seen such image in many of the movies, and at the bottom of it you will find oceans. So this is a sea cliff. बहुत लोग जैसे कूद के जान मान लेते हैं. So this is a sea cliff, steep rocky coast rising almost vertically above the seawater. Now all these things are relatively easier. What is interesting is work of ice. See what happens on the mountains, glaciers will be deposited. Now these glaciers are very big and very bulky. They have a lot of weight. Because of this weight, what will happen? The underlying mountain portion will be bulldozed, will be slowly crumbling under this weight. इसके वजन से धीरे धीरे नीचे क्या होगा? टूटता रहेगा, withering होती रहेगी. And as it will be withering, the water will be seeping inside and it will be replacing it. So for a huge, for few so many years, it will almost create a deep ice lake because of the sheer weight of the glaciers. After some time, when this glacier will melt, this region will be filled by water, and it will lead to create of beautiful lakes in the mountains. So all these lakes that we show, Kailas, Mansarovar Lake, many lakes in Srinagar, these are created by these glaciers. So ice melts and they get filled with the water and become beautiful lakes in the mountains. Now, this part which was breaking, you may ask this question, that the part of the mountain which is breaking because of this pressure of the glacier, where is it going? This part is known as glacial moraines. So these are materials carried away by the glaciers. क्या हुआ, ग्लेशियर जब मेल्ट करेगा, some water will move inside, or sometimes the whole glaciers, you might have seen image of avalanche coming and the whole piece of uh, ice falling down. So with that, they will carry these particles, sometimes even rocks also, and they will get deposited in plains. And these will create glacial moraines, which are very, very fertile. In regions of Srinagar, Dehradun, you will find these glacial moraines which makes the soil fertile. Now the work of wind. We'll read about this in great detail in class 11th. Again, we have to read different kind of dunes, perchance and बहुत कुछ हो, moon shaped, crescent shaped, flat shaped, क्या क्या बनता है सब पढ़ेंगे. But let's have a small debate here about this. Wind is an active agent. It continuously work on erosion. Let's suppose there is a rock. Air is blowing continuously. Now this air has a lot of dust particles with it. If you have ever been in a ever been caught in a dust storm, you might have feel कि the sand particles actually hit very hard on legs. किसी ने फील किया है क्या कभी? इतनी तेज हवा चलती है कि हमको भी चोट लगती है वो डस्ट पार्टिकल्स से. Now consider such kind of a bombardment happening on this rock surface continuously for years. Because of that, it will start eroding some part of the outer layer of this rock, wherever the rock is hitting. Now, air is most active at the bottom. As we go up, the force of this wind will go low or will go down. So what will happen? You will find more erosion on this part. Slowly it will keep on eroding this. And those who are from Rajasthan or probably even Madhya Pradesh, you might have seen rocks which are like this, where bottoms are eroded. It has become very thin and the top is still bigger than the bottom. And these creates mushroom rocks. And they also create sand dunes. A very interesting term has been mentioned here, that is loess. What happened in China and some other parts of the world, that these sand dunes, sand particles are carried away by air to very long distances. In India also, we have our desert in Rajasthan, the great Indian desert. There's a problem of desertification. I hope many of you have heard the word desertification. Now, the desertification is the process in which the air carries the sand particles and spread it into the fertile regions. So अभी मान लो कि यहीं तक डेजर्ट था, but हवा क्या करेगी? They will carry the sand and it will spread into other areas. Slowly this will keep on increasing, and more fertile land will become desert. To stop that government and local people use many local practices. One of the best practices, planting trees. If you plant trees at the border of the deserts, the sand will not spread. The air velocity will be stopped by that. Then quite opposite thing happened with loeses. Loeses, especially in China, are very fertile. Many of you might have heard the name of Yellow River. नाम सुना है येलो रिवर का? द सॉरो ऑफ चाइना. स्कूल के टाइम में थोड़ा थोड़ा याद आ रहा होगा. नहीं सुना? So Yellow River is China. Yangtze River. It's known as the sorrow of China because it used to flood a lot. It was like Damodar in India. Now Chinese have created great dams on this and they have tamed this. And this is known as yellow river because these loases, which are specifically yellow in color, they have surrounded this river and some of the particles are also found in the water. Now, these loases are sands only, but they are fertile. And that's a mystery, that how can sands be fertile? They do not have humus. We'll read in the next few chapters about humus. Humus is basically the dead organic constituent of soil. ऑर्गेनिक मतलब प्लांट का लीव्स हो गया, एनिमल्स के डेड डेड एनिमल्स के bones, skins हो गए. All these things provide organic constituent to the soil, and wherever there is no humus, the soil is infertile. Without humus, nothing can grow. This is the common understanding. Now in loases, you will not find humus, and still they are fertile. So let's read this, why they are fertile. The loases tend to develop into very rich soils, and under appropriate conditions, it is some of the most agriculturally productive terrain in the world. The China owes a lot to these loases because this Yellow River area is known for being one of the highest fertile regions. Why is it so? कहते हैं the fine grains wither rapidly due to the large surface area, making soils making soils derived from soluses rich. क्या हो रहा है? A lot of sand particles, small sand particles, have been carried in this region. If we let's draw the map of China. So it's something like this, right? This is our Himalayas. Now loases are mainly found in this region, the Tibetan area, and they're carried away from this Mongolian. The desert is being carried away from the Mongolian region, and they are deposited at the foot of our great Pamir Plateau. So this region, यहाँ क्या हो रहा है? ये जब सोलासिस आके यहाँ लोएसिस जब आके यहाँ डिपॉजिट हो रही हैं, they have very large surface area, and because of large surface area, they are rapidly withered. Can you understand this line? ये बात समझ में आ रही है सबको क्या कहना चाह रहा है? Due to large surface area, they rapidly withered. Let's test your English and science. What's happening? These loases has large surface area. What does this mean? You have a flat surface and you have a surface made up of loases, which will have more surface area. A flat condensed surface or a surface made up of this loases. Loases will have high surface area. Now, if withering has to happen on this surface, it will only happen on the top layer. Like whatever is working, whether it is water or soil or air or animals, whatever is working, it will only work on the top surface. But for loases, the withering can happen at the inner level also. Water can seep down and will break down these soil particles much faster. And because they will break down much faster, they will quickly convert into soil. So the one theory states that the fertility of the Loess's soil is largely due to cation exchange capacity, the ability of the plants to absorb nutrients from the soil. Cation exchange क्या होता है? Now, if you are from science background, if you have read science or at least till class 10th, you can remember anions and cations. They're the positive and negative charges. How water gets its food? Water gets its food through the interaction of the charges. These cations basically go up to the roots and leaves in the plants and give the required nutrition. You don't need to go into the details of it, but इतना cation exchange हो सकता है. The more cation exchange, more nutrition plants can draw. And because of this more cation exchange and more porosity, because air can penetrate deep into this loases, there is more air there, and this make the loases fertile. ठीक है, थोड़ी बहुत बात समझ में आई. It's quite interesting to know that deserts can lead to more fertile soils, quite opposite to what happened in our country. So the loases, somebody is asking कि loases फिर से explain कीजिए. Loases कुछ नहीं है, it's a sand deposit in large areas. Simple है, मंगोलिया से सैंड चलता है, आके तिब्बत में डिपॉजिट हो जाता है. जो सैंड डिपॉजिट यहाँ होता है इसको लोआसिस बोलते हैं और लोएसिस बोलते हैं. And they are fertile. That's all you need to know. This is the end of this chapter. Let's do some exercise. ये बताओ मुझे, what's happening here? This is waterfall. What's happening? Erosional or depositional? What is the type? What water is doing here? It's doing erosion or deposition. Quickly. Erosion. Good. What's happening here? What is this? What is the name of this feature? Quick. The lay meanders. Correct. So this is meandering. River is meandering. Meanders. What is the feature? Erosion or deposition? Yes, only one. Hitin का answer ठीक है. Sarkar is also saying the same thing. So it's both. क्या हो रहा है meanders में? थोड़ा सा अगर हम लोग याद करें what the conversation that we have, कि on one side there will be erosion and the other side there will be deposition. So erosion and deposition goes on side at the same time. What's happening that a river is eroding here and it's depositing whatever it has eroded here. So erosion और deposition दोनों साथ साथ चलता रहता है. We will read that in detail later. But both happens here. Continuous erosion and deposition. अब आते हैं air में, and now I need all of your scientific knowledge. So be ready. We have already talked about atmosphere. It's a huge blanket of air called atmosphere. It protects us from the harmful effects of sun rays. Now, greenhouse effect. We have discussed about this. Earth act as a greenhouse. What does that mean? That it allows the sun rays to come in, but it doesn't allow it to go out. क्या कहते हैं? Carbon dioxide release in the atmosphere creates greenhouse effect by trapping the heat radiated from the earth, and this is called greenhouse gas. Carbon dioxide is a greenhouse gas. Without it, the earth would have been too cold to live in. Now, let us understand this in a little bit detail. All of you know about waves. वेव पता है सबको? वेव क्या होता है? This is a wave, right? Anything which is moving in a oscillating manner, to and fro, parallel, oscillating manner में movement हो रहा है. It's a wave. Now wave में, those who have read in science, wave, this is a special kind of wave. क्या है ये? इसको कहते हैं साइनोसोडल वेव. जरूरी नहीं है, अभी बस वेव याद रखो. वेव में we read about two things: amplitude and frequency and wavelength. Three things. सबको पता है फ्रीक्वेंसी, वेवलेंथ, एम्पलीट्यूड क्या होता है? Who will explain? एम्पलीट्यूड, फ्रीक्वेंसी, वेवलेंथ कौन बताएगा? जल्दी. Who will explain? हाथ उठाओ जल्दी. कोई नहीं. हाँ, दिव्या बताएगी. दिव्या बताओ.
The distance between two amplitudes is called a wavelength.
Difference between two amplitudes. What is amplitude?
We can say it as crust and troughs. Distance between a crust and trough.
What is crust and trough?
In a wave, we will have the highest amplitude and the lowest amplitude. So distance between that, the repetition pattern is called wavelength.
Okay. ठीक है, थोड़ा सा इसको डिटेल से समझते हैं. So see, this wave is, thank you Divya, the wave is moving like this. This is the highest point of the wave and this is the lowest point of the wave. The highest point is crust and the lowest point is trough. Now the difference between two highs or two lows is known as wavelength. Wave का length कितना है? Wave is starting from here and returning to its original position at here. So this is the wavelength. Now you can have waves of different lengths. So the very good image of this you might imagine whenever you have dropped or thrown a stone in a pond, you will see the ripples originating. Now some ripples in the beginning, जहां पे तुमने स्टोन फेंका होगा अगर तुम देखो तो there you will find the ripples will be very close by, and as you go far you see that it's spreading. So what does this mean? That here the wavelength is very less, the distance between two tops is less. Here the distance between two tops is high. So as it's moving away, the wavelength is increasing. So depending upon this, you can have different kind of waves. The short waves, the long waves. ज़्यादा wavelength के waves हो सकते हैं, कम wavelength के wave हो सकते हैं. Now, what is frequency? Anyone? What is frequency? Kapil is saying frequency is number of cycles completed per second. Okay. Number of waves in 1 second, number of oscillations in wave 1 second. Good. So see, those who are from non-science background, let's break it down. This is your wave. Sorry for the drawing. So this is your wave, right? Now, your wavelength is this. From this point to this point is your wavelength. Now, let's suppose in 1 second, in 1 second time, this wave which has started from here is able to go here and again come back here. So मान लो कि इतना distance travel करता है, यहाँ से start होता है यहाँ तक जाता है. So in this what we can say that in this time the wave has made how many oscillations? 2 oscillations. 2 oscillations का मतलब क्या हुआ? One oscillation is, in a pendulum you have heard about oscillations. So oscillation is you start from one point and return to the same point. So this completes your one oscillation. Similarly, this wave has started from this top, it went down and came back to this point. So this completes its one oscillation. And this is the second oscillation. Similarly, it will be doing and going for the third oscillation. So let's suppose in 1 second, it's doing 2 oscillations. So इसको बोलेंगे इसकी frequency. 1 second में कितनी बार ये oscillate करता है. So if a if a wave is moving at a very high speed, it will oscillate a lot many times within that peak. So higher the velocity, more will be the frequency. ऐसा imagine कर सकते हो. Frequency. Now some of you are saying that frequency is 1 by lambda or 1 by wavelength. So this wavelength is denoted as lambda. Sign याद रख सकते हो. Frequency is denoted by mu. These are Greek letters. So mu. 1 mu is equal to 1 by lambda. अब थोड़ा और इसको डिटेल से आज देख लेते हैं. Let's talk about energy of the waves. When it's moving, it has some energy. That's pretty common. Move कर रहा है तो energy होगा, because energy nothing can move. So how much energy a wave will have? The normal idea. Now we don't need to go into the science. जिनको science नहीं भी पता है वो बस इतना थोड़ा सा समझो. किस तरीके की वेव में ज्यादा एनर्जी होगी? The faster it is moving, the more energy it should have. तुम अगर देखो एक 10 किलोमीटर स्पीड से चलती हुई बाइक से टकराओगे, और अगर तुम एक 100 किलोमीटर स्पीड से चलती हुई बाइक से टकराओगे, यहाँ तो तुम मुझे शायद रोक लोगे, यहाँ तुम भी उड़ जाओगे, बाइक वाला भी उड़ जाएगा, बिकॉज इट हैज मोर force, more energy. So higher the speed, more energy. So we can say कि energy is proportional to frequency और mu. ठीक है, energy is proportional to mu. इसी को इंग्लिश में, मतलब इंग्लिश में नहीं, साइंस में लिखते E is equal to h nu. H is the Planck's constant. Those who know the science probably can remember H is the Planck's constant. Energy of any wave is equal to h nu. Now this can also be written as H is equal to E is equal to h into 1 by lambda. Lambda is the wavelength. So what you can understand, if a energy has very high wavelength, it will have less energy. You can write it down, especially non science वाले, क्योंकि फिर explanation तुमको इस तरीके से नहीं मिलेगा. So higher the wavelength, and I'm sure that many of the science background students might have forgotten these. So higher the wavelength, in bracket write lambda, higher the wavelength, lower the energy. And vice versa. You can say lower wavelength, higher energy. And in case of frequency, अब समझ में आ रहा है ना पलक के सेइंग कि साइंस तो स्टार्टिंग से बाउंस मार के निकल गई है. इतना समझ में आ रहा है ना, जो बता रहा हूँ समझ में आ रहा है. Don't get afraid of science. Science is very, कुछ कुछ ही आ रहा है, कुछ कुछ नहीं आना है, सब समझ में आना है. क्या नहीं समझ में आ रहा है? देखो, वेवलेंथ समझ में आ गया ना. दो हाइट के बीच का डिफरेंस करेंगे तो इसको वेवलेंथ बोलेंगे. इतना समझ में आ गया. तो अभी तुमको अगर दो वेव दिया जाए और उसको बोला जाए कि तुम बताओ कि किसका वेवलेंथ ज्यादा है, तुम देख के बता सकते हो कि किसका वेवलेंथ ज्यादा है. जो ज्यादा तेजी से, जिसका ऐसा छोटा छोटा जिसमें बन रहा होगा, उसका वेवलेंथ कम होगा. जो ज्यादा बन रहा होगा उसका वेवलेंथ ज्यादा होगा. इतना तो तुमको समझ में आ गया सबको. अब ऑसिलेशंस एक सेकंड में कितनी बार ऊपर नीचे कर लेता है वो, बस वही है. एक सेकंड में तुम कितने उठक बैठक कर सकते हो, वो तुम्हारा ऑसिलेशन है. तो वैसे ही विंड का, वैसे ही वेव का है कि एक सेकंड में कितने बार ऊपर नीचे कर लेगा. दैट्स इट्स ऑसिलेशन. ठीक है. और ऑसिलेशन या फ्रीक्वेंसी को 1 बाई लेमडा कहते हैं. अब इसको मैं नहीं डिराइव कर रहा हूं, ये याद रख लो. आगे, हाँ हम कहाँ थे, एनर्जी वाली बात कर रहे थे. तो ये थोड़ा सा याद रखो कि कम वेवलेंथ मतलब ज्यादा एनर्जी. ये रिलेशन समझ में आ रहा है ना. कम वेवलेंथ तो कैसे ज्यादा एनर्जी होगी. मान लो एच का वैल्यू ये सब मान लो कि ऊपर 1000 है, ए इज इक्वल टू 1000 है. जैसे जैसे लेमडा बढ़ेगा वैसे वैसे ई कम होता जाएगा. तुम अगर लेमडा 100 रखोगी तो एनर्जी 1 हो जाएगा. अगर लेमडा तुम 1000 कर दो तो एनर्जी 0.1 हो जाएगा. सो दिस इज सिंपल. हायर द वेवलेंथ लोअर द एनर्जी, हायर द फ्रीक्वेंसी मोर एनर्जी. अगर फ्रीक्वेंसी 1000 हो जाएगा तो एच से मल्टीप्लाई होगी वो 1000 एनर्जी हो जाएगा. 1,00,000 हुआ तो 1,00,000 हो जाएगा. सो दिस इज सिंपल. नाउ लेट्स थिंक अबाउट स्पेक्ट्रम. देखो, in our world, in the world that we live, there are fixed number of or fixed types of waves. ये जो वाइब्रेशन हो रहा है वो बहुत, ऐसा नहीं कि अनलिमिटेड काइंड ऑफ वाइब्रेशंस हो सकता है. एक एक लिमिट है अपने पास जिसमें वाइब्रेशंस को हम एटलीस्ट देख पाते हैं. So there will be waves which are of very small length. एक बार मैं निकालता हूं और तब वहां डिस्कस करते हैं. दैट विल बी मच मोर क्लियर. देखो, ये चीजें मैं बता रहा हूँ बिकॉज I have seen many students does not know this, and because of that उनकी यूपीएससी की वाट लग जाती है, क्योंकि ये सारी चीजें कहीं कोई पढ़ाते नहीं है और बहुत सारे स्टूडेंट ये पढ़ के नहीं आते हैं. एंड आई नो दिस बिकॉज आई हैव सीन स्टूडेंट्स. So this is Earth's. This is all kinds of waves that penetrates the Earth's surface, which are there in the Earth's surface. Now, looking at this, can you tell me which has the higher wavelength and which has the lower wavelength? Left में ज्यादा wavelength है या right में ज्यादा wavelength है? Left में wavelength ज्यादा है. So here you can see that the difference between two highs are very big, and as we are moving in this side, the length is slowly declining. तो इतना तो अपने को पता चल गया कि wavelengths are higher here, wavelengths are lower here. Now these wavelengths with high, these waves with high wavelengths, इनमें क्या होगा? हाई वेवलेंथ का मतलब क्या है कि ये देखो क्या लेंथ है बता रहे हैं, वेवलेंथ इन मीटर्स. तो रेडियो वेव्स का क्या है, 10⁻³ मीटर के आसपास इनका वेवलेंथ है. मतलब कि वन डिफरेंस बिटवीन टू पीक्स ऑफ अ रेडियो वेव इज अबाउट 1 किलोमीटर. मतलब एक बार पीक पे आया, फिर नीचे गया और फिर ऊपर आया, तो it will be 1 kilometer long about. Now this will have high energy or low energy? This wavelength, this wave which is very high wavelength will have low energy or high energy? Will have low energy. That means कि if you will come into the contact of radio waves, it will not do anything to you. तुमको बहुत हार्म नहीं पहुंचाएगा रेडियो वेव. It will pass on, you will never feel that there is any interference. So around us, the radio waves are all around us. Your phone is continuously emitting radio waves, but it doesn't impact us because the energy is very less. As we move towards this, we come to microwaves. Now, as the name suggests, these are micro in nature, and the size is 10⁻⁻². So these will have more energy. These microwaves are used in your microwave ovens. So when these microwaves will start moving, they have energy and they will heat up the things. समझ में आ रहा है? Because they have more energy. So when they will move, they have energy, they will collide and they will give their energy to the food particles, microwaves. You come ahead and you will see infrared. Now size is 10⁻⁻5. So difference between one peak to another peak is now 10⁻⁻5 meter. This will be much more hotter than this. So infrared is your iron getting hot. When your iron is hot, it is emitting infrared. You feel heat. The size of these waves is almost of the size of the needle, for a comparison, needle point. Then you have visible electromagnetic waves, visible waves. So this light that we see, light is what? Light is a wave, right? So we cannot see all the lights. We cannot see radio waves. We cannot see microwaves, infrared, ultraviolet. कुछ भी नहीं दिखता है. Only we can see these visible rays, visible range. Our eyes are made or customized to see only these visible range of waves. So ये जो 0.5 into 10 to the power 6 ये प्रोटोजुआ के साइज के जो waves हैं वही हम देख पाते हैं. Now in this visible range you will find this, probably you have read, VIVGEOR. Violet से लेकर और रेड तक. So all these colors are between this visible range. Moving forward, we have ultraviolet rays which are harmful to us. We have X-rays and gamma rays. Now you can see कि infrared और microwave में इतना energy है. What kind of energy gamma rays will have? You might have watched the movie Hulk. Hulk देखे किसी ने? हल्क नहीं देखा हुआ तो कम से कम क्या बोलते हैं एवेंजर्स तो देखा होगा. So in Avengers you see a character who is always angry and beating the things. If you see his past, he was hit by a gamma ray. He was a scientist and suddenly he came into the way of the gamma rays, and that gamma rays changed all his molecular structure. So gamma rays are very, very dangerous because they have a lot of energy. So now I hope that this makes sense to you कि क्या होता है short wave and long wave. So higher wavelength it will not impact you, lower wavelength it will impact you a lot. So short frequency is dangerous. Now if you will see frequencies, so here you have 10 to the power 4 ka frequency. So these radio waves, in 1 second this radio wave will be traveling so fast that it will cover, it will move from one top to another 10 to the power 4 times. मतलब 10,000 बार ऊपर नीचे कर लेगा एक सेकंड में. And this gamma ray is traveling so fast that it will like 10 to the power 20 is, I don't know how much it is, what it is. Like कोई वर्ड भी है उसके लिए, मुझे वो भी नहीं पता. 15 तक तो शायद पेंटा बोलते हैं. 20 के लिए क्या वर्ड है याद नहीं आ रहा. So it will be traveling like in 1 second, its waves will make so much move. Now to travel so much fast, you can imagine ki what kind of energy it has. Temperature wise also you can see here, the radio waves have no temperature. You will not feel that much heat. But as you start moving upward in this region, more and more and more heat. Now you can also understand the 5G controversy now. When we are talking about this, let us settle this also. Currently, the radio waves are operating in this region. These are not harmful to us because they are of very less energy. But 5Gs are moving now towards this region where they have more energy. Why companies are moving to 5G and why they are moving in this region? Because when they have more energy, they can travel fast. When they can travel fast, they can carry your data fast and they can carry more data as well. But when they are moving towards this direction, it will have more energy. When it will have more energy, it will interfere more with humans, with birds, with insects. So it will not remain as innocent as the radio waves were. And that's why many environmentalists are opposing these 5G installations. बात समझ में आई? जिसको समझ में आ गया हो, मेरा मैं घर का अपना एड्रेस दे देता हूँ, मेरे यहाँ मिठाई पहुंचा देना. नहीं समझ में आई तो फिर जाके दोबारा रिकॉर्डिंग सुनना. Clear to all? Completely off the topic, but I thought that something that all of you should know. आगे बढ़ते हैं. Let's come back to our. Let's come back to our topic. So waves, amplitude. Yes, let's talk about amplitude. One more thing that we missed here. See, this height is known as amplitude. So how high from the base a wave is rising? This is known as amplitude of the wave. So the higher it is, the higher will be the amplitude. Amplitude you can generally consider, let's compare two sound waves. Sound waves to thoda alag ho gaya. Let's compare two electrical waves, and if you increase the amplitude, what will happen? It will generally increase the strength of it. जैसे sound wave में अगर amplitude की बात करें तो when you increase the volume, you are actually increasing the amplitude. जब भी तुम वॉल्यूम इंक्रीज करते हो तो क्या करते हो? एम्पलीट्यूड इंक्रीज कर रहे हो. नाउ we talked about one kind of waves. These are longitudinal waves because they are traveling in a longitudinal fashion. सामने की तरफ, या इसको longitudinal या transverse waves कहते हैं. They're traveling in a, सॉरी उल्टा बोल गया मैं, longitudinal नहीं, ये transverse wave है. They are traveling in a up and down fashion, like traveling on both x and y axes. सामने भी मूव कर रहे हैं और अप डाउन भी मूव कर रहे हैं. We will discuss in some other class about sound waves. Sound waves doesn't move like that. Sound waves move in a to and fro manner through compression and expansion. तो वो अलग तरीके का वेव है. We will talk about that later. अभी तक जिनको ज्योग्राफी आसान लग रही होगी अब थोड़ी मुश्किल लग रही होगी, because if you do not know the science, geography is difficult. Now coming to greenhouse effect, why did I made so much effort to make you understand this? See, this is your earth and this is your atmosphere. Now the sun rays are coming. When sun ray is coming, it has a lot of heat and energy with it, right? So when it has a lot of heat and energy, it is a long wave or the short wave. किसी वेव के पास अगर बहुत एनर्जी है तो इट्स a long wave or a short wave? बोलो बोलो जल्दी बोलो. It's a short wave because wavelength is very small, then only it has energy, so it's a short wave. So all the light which is directly coming from sun is coming in the form of short waves. It enters into the earth's atmosphere, it collides with the earth's surface, gets a little bit cooler, and then it's reflected back to the atmosphere. Now when it is coming back, it has lost its energy. Now it is short wave or long wave? It is long wave. It has lost its energy. अब उतना हीट तो अर्थ नहीं रेडिएट कर रहा है जितना सूरज रेडिएट कर रहा है. So it is long wave. Now there is a special property of carbon dioxide or greenhouse gases. Greenhouse gases are like windows. They're not like doors. They're like windows. So the smaller people can pass through the windows. So the smaller waves will pass through this window. So carbon dioxide will allow the sun waves to come to the Earth's surface. But when the long waves will come, they will say प्राण जाए पर बचन न जाए. अमिताभ बच्चन नहीं निकल पाएंगे इस खिड़की से, and long waves will be trapped inside. So these long waves will be trapped inside and will slowly heat the overall environment of the Earth. Now I think for the first time many of you have understood कि greenhouse effect होता क्या है. समझ में आया? Carbon dioxide will allow the short waves but not allow the long waves. You will see the same phenomena. Probably I have discussed. If I am repeating again, तो कोई बात नहीं. In USA, there are laws that you cannot leave your toddlers, your babies, in a car with closed windows. And if police will find that you have left your child in a car with closed windows, you will be charged with heavy punishment, like murder जैसा चार्ज लगेगा तुम पे. Why is it so? कार में बच्चे को छोड़ दिया तो ये क्या कर दिया. देखो, what is a car? Car has glasses. Now glasses are same as carbon dioxide for the earth. They will take all the sunlight in. They will take all the heat which is present in and convert them into long waves. And within minutes, the car will become microwave. And there are many cases where children have died in the car. Many cases in USA. And then that's why they were forced to make this law. You also might have felt if you are rich enough to have a car. कि जब कार खोलते होगे तो लगता होगा कि 5 मिनट खोल के अगर तुम गए दुकान से वापस कार में आगे बैठोगे तो लगेगा कि ओ कहाँ आ गए. फील किया है सबने? So that's the same. The greenhouse effect is happening in your car also. Nevis is asking carbon will trap the heat wave or the cool wave. It's not about heat wave or the cool wave. It's not cool. It's relatively colder. ऐसा नहीं कि वो ठंडा हो गया आके एकदम ठंडी ठंडी हवा चल रही है धरती से. It's not cold. It's relatively cooler. सूरज जैसा धकता गोला नहीं है अर्थ ना. It's relatively cooler. And that's why it has longer waves. ठंडी हवा नहीं है वो. गर्म हवा ठंडी हवा मत सोचो. शॉर्ट वेव एंड लॉन्ग वेव. Compared to sun, it is cool. हाँ, अरे स्कूटी की सीट गर्म होना और कार का इंटीरियर गर्म होना इज वेरी डिफरेंट थिंग. स्कूटी की सीट तुम्हारा वहां ग्रीन हाउस इफेक्ट नहीं काम कर रहा है. पलक इतना कंफ्यूजन हो रहा है क्या तुम लोगों को? ग्रीन हाउस इफेक्ट समझ में आ रहा है? आई एम टेलिंग ग्रीन हाउस इफेक्ट. वार्मिंग ऑफ, तुम धूप में खड़े हो तुम्हारा चमड़ी जल जा रहा है तो ग्रीन हाउस इफेक्ट नहीं है. If you have a house with glasses, जिसके घर में शीशे की ग्लास लगी हुई होगी, तुम्हारे पास तुम्हारे घर में अगर 2 कमरे हैं, in one house you have glass window and one house you have wooden windows, you will naturally feel that the house with the glass windows get heated more than the house with the wooden windows. The same thing is happening. The short waves are coming in, the long waves are not going out. Your house has become a greenhouse. Your room has become a greenhouse. ठीक है, तो घर में जो लोग शीशे लगवाते हैं वो लोग थोड़ा सतर्क हो जाए. It will increase more heat. Now, those who are really rich, you may ask then why these rich people have glass houses? Are they so idiot? No, there are glasses, special kind of glasses, which do not allow the short waves to come into. Conduction proof glasses आते हैं, very costly. बट हम लोग तो अंबानी को देख के अपने घर में भी वो सस्ता वाला ग्लास लगवा के और अपने लिए ग्रीन हाउस इफेक्ट क्रिएट कर लेते हैं. But when you know the science, why long waves is not going out of the. अरे बाबा, कहाँ हो देवेश, कहाँ हो, क्या कर रहे हो तुम, क्या करते हो देवेश? I want to see you. What do you do where you are? बताओ मुझे कोई, इतना बुरा पढ़ा रहा हूँ मैं क्या, क्या अभी तक ये नहीं होना कि why heat wave will not go out? समझ में आ रही है बात, क्यों हीट वेव नहीं जाएगा? Anybody can explain? सिंपल, मैंने कितना बढ़िया एग्जांपल दिया ना कि द कार्बन डाइऑक्साइड इज एक्टिंग एज अ विंडो. इससे अच्छा एग्जांपल तुमको नहीं मिलेगा कहीं. दिन में 1000 किताब पढ़ लोगे बट नहीं समझ में आएगा. इट्स अ सिंपल थिंग. द कार्बन डाइऑक्साइड इज acting, or the greenhouse gases, not just carbon dioxide, all the greenhouse gases, they act as a window. They allow the short waves to come in, they do not allow the long waves to go out. Now if you want to go into details of it, कि why high long waves are not going out, then it's more technical. It's a lot technical. अगर ये बात नहीं समझ में आती है लॉन्ग वेव्स क्यों नहीं जा रहा है, ये समझना और मुश्किल है. Now, it's because of the chemical properties of carbon dioxide. They interact with hot waves. They observe their frequencies. अब ये बात तुम्हारे ऊपर से निकल गई होगी. How they observe the frequencies. तो उतना मत याद रखो, इतना एग्जाम में लिखना है. एग्जाम में क्वेश्चन भी यही आएगा that greenhouse gases allow the short waves to pass through. Hot short waves to pass through, and they will stop the radiated long waves to pass through them. इसको नहीं जाने देगा, इसको जाने देगा. ठीक है, देवाश्री. धैर्य की परीक्षा ले लेते हो तुम लोग मेरी. आगे बढ़ते हैं. इतना पढ़ाने के बाद अगर किसी को ना समझ में आए तो हाथ में डस्टर हो तो फेंक के मार दिया जाए. कोई बात नहीं, चलो. दैट्स द बेनिफिट ऑफ बीइंग इन द लाइव क्लास. कहाँ थे हम? तो ग्रीन हाउस इफेक्ट समझ में आ गया. अब सोचो कि अगर बहुत ज्यादा कार्बन डाइऑक्साइड हो जाए, बहुत ज्यादा ग्रीन हाउस इफेक्ट हो जाए, so they will start trapping more and more and more heat, and earth will become more warm than it is required, and then that process is known as global warming. We have read about the constituent of atmosphere: nitrogen, oxygen, and all others. Now, ये बहुत मजेदार है. We have read about the structure of the atmosphere. We have read T-shirt में thermal, and last one is exosphere. Now, how the temperature changes in this region is very interesting. फर्स्ट देखे तुम लोगों का साइंस का ज्ञान. Can anybody tell me the difference between heat and temperature? The difference between heat and temperature. Heat is a field. Divya, you are wrong. Temperature is a measure of hotness and coldness. Heat is an energy. चलो देखते हैं, बहुत मजेदार कॉन्सेप्ट है, you will enjoy this. So the temperature in all these regions, that's what we are trying to check. Okay, what is the impact of temperature? Now, for a layman, those who do not know geography or science, for them what should happen? That the area which is the region which is closer to the sun should be the hottest, and as we move towards the earth, it will be more and more cooler. So the idea should be कि as we will go up, temperature should increase. Right? Normally तो लेमैन के लिए यही होना चाहिए कि हम ऊपर जाएंगे तो वी आर गोइंग मोर क्लोजर टू द सन, तो टेम्परेचर शुड इंक्रीज. ठीक है, बट दिस इज रॉन्ग. It doesn't happen like that. Now what is the reason? ये बात समझ में आई ना कि मैं क्या कहना चाह रहा हूं. अब देखते हैं कि होता क्या है. What is happening in reality? See, the region up to the troposphere, which is about on an average 10 kilometer, it varies from 18, average height is 13 kilometer. So it varies from 10 kilometer to 18 kilometer. So you will see the earth. If this is earth and this is equator and these are poles. So at the equator, the height will be more. And as you will go towards the pole, the height will be less. Height of troposphere will be less. On an average, it is taken as 13 kilometer. So in this region, as we go up, the temperature starts to decline. This line is for temperature. So when we're moving towards this, the temperature is rising. So if we move towards this, the temperature declines. Why is it happening? Why is it not following this model? Anyone? हमने शायद जिक्र किया भी है. Why it's not getting hotter as we are moving more closer to sun? As we move towards the sun or we go away from the earth, the temperature declines. हमने पढ़ा है ना, higher we go, cooler we feel. So why is it happening? Why the temperature is declining as we are going up? The conventional wisdom tells that as we move closer to the sun, the temperature should rise. But एनर्जी तो सन से आ रही है ना. देखो, understand this. All the energy that we get here in the troposphere is, most of the energy that we get here is the energy which is radiated by the earth. We get the radiated energy. ये क्या हो रहा है, हम लोगों को जो एनर्जी मिल रही है वो रेडिएटेड एनर्जी है. So the impact of sunlight is not that high here. The impact of this radiated energy from the Earth's surface is very high. So as we move away from the sun, the effect of this radiation will get lesser and lesser and lesser. ठीक है, ये बात समझ में आई? Because the troposphere is heated by the earth. The troposphere is not heated by the sun. Troposphere is heated by the earth. And as we move away from the earth, we feel cooler. But after 13-14 kilometers, the impact of this radiation almost diminishes. Now, Earth cannot heat the atmosphere more than 10 kilometers. So now we have started moving closer to the sun, and the temperature will start increasing. So from 10 kilometer to about 40 kilometers in the stratosphere, the higher we go, the hotter we feel. जितना ऊपर जाएंगे टेम्परेचर उतना बढ़ता जाएगा. ठीक है, दिस इज क्लियर टू ऑल? जल्दी, यस, नो? Till the troposphere temperature will decline, after that it will start increasing. Good. Now in the mesosphere again, the temperature will start declining, and it will reach up to, it will go in zeros as well. Now why this is happening? Because in mesosphere the particles are very less. There is nothing to heat. Compared to a stratosphere, the relative temperature is less because particles ही नहीं है कि गर्म करे उस amount में. And the kind of particles which are there, they absorb the heat. ये mesosphere का याद रखना है. इसके लिए बहुत plausible explanations even I have not been able to find. But you must remember this, that in mesosphere, mesosphere acts as troposphere. The higher you go, the cooler you will feel. The temperature will again start to decline. Now in thermosphere, as the name itself is thermosphere, because in this, again, the temperature will start rising. And in exosphere, it will continue to do so. तो हम क्या देख रहे हैं, एक zigzag पैटर्न बन रहा है. फर्स्ट गो डाउन, देन अप, देन डाउन एंड देन अप. बस यही याद रखना है, कुछ मत याद रखो, ये पैटर्न याद रखो. ट्रोपोस्फियर में गो डाउन, this is easy to remember now because of Earth's radiation. In stratosphere, it will start to go up as we are moving closer to the sun. In mesosphere, it will go down. And then in thermosphere, again, it will start increasing and keep on increasing in exosphere as well. And the more closer to the sun you will get, more hot you will feel. The only exception you can say is troposphere and mesosphere. Now, all the weather phenomena that we see, that will be happening in the troposphere. All the rainfall, cloud, everything that you see will happen in the troposphere. Nothing will happen above it, because the atmosphere is not that dense. Clouds will not go higher than 13 kilometers or 18 kilometers in the case of equator. Stratosphere, the second layer क्या है? This is the region of calm. इधर कुछ नहीं है, nothing is happening. So in this region, aeroplanes will fly because there are no clouds, no problem. So this will extend up to 50 kilometer. They are free from clouds and weather phenomena. In this region, you will find ozone gas. So the ozone layer is in stratosphere. And then you have mesosphere, and we have already discussed that meteors burn up in this. And then we have thermosphere. In thermosphere, you have ionosphere. Now this is very important. How many of you have heard radio? कितने लोगों ने कभी रेडियो चलाया है? Lot of you. Now, have you experienced that during the night times, the radio signals are much more clearer than the daytime? I'm not talking about FM. FM में ज्यादा इम्पैक्ट नहीं पड़ता है. जिन्होंने SW या AM चलाया होगा, शॉर्ट वेव्स या AM से चलाया होगा, उन्होंने देखा होगा. So what I used to do when I was in 9th and 10th, I had a radio. And I had this fascination to listen to BBC News. तुम लोग सोच सकते हो कि मैं कितना. Some people say that I was made for UPSC preparation. I was listening to BBC News when I was in class 9th and 10th. Now, my radio didn't had the kind of antenna which was which can easily capture BBC News. And the BBC News used to come early in the morning about 7:30 में खल्ला बोल बोल के उनका कार्यक्रम आता था और 5 बजे के आसपास कोई बुलेटिन आता था. So I will not be able to listen to their day broadcasts, but during that early morning time, if I can get the frequency right, I used to get to listen to those broadcasts. It was a very nice experience. काफी entertaining और काफी अच्छा न्यूज ब्रॉडकास्ट करते थे. Now, why this is happening? That's the reason. That's the discussion of today. See, इसलिए मैंने इतने डिटेल से तुमको वेव्स पढ़ाया है. We have read about radio waves. Now, how radio waves are mainly the waves that we hear. तुम लोगों ने दो चीजें देखी होंगी रेडियो में, AM and FM. AM is, anybody, full form? Amplified modulation. And FM is frequency modulation. Now, let's take a simple example for those who are for non-science background. This is your wave. Okay, wave hai. This is traveling. Now, on this, two kind of modulations can be done. Modulations is changing the wave. So you can make two kind of changes. One is amplitude modulation. As I told you, when you increase the volume of your TV, you increase the amplitude. You must have heard that song, "Tu Mera Amplifier." सुना है ना? कौन सा गाना था? बुफर तू मेरी. The amplifier amplifies something. So amplifier is increasing the amplitude. So what we have read, it will increase the height of the waves. So this is your amplifier. So when the radio station, there is a radio station who broadcasts the signal. So when they will send an amplitude modulated wave, when they want the frequency to increase, sorry, the amplitude to increase, they will do the amplitude modulation and send it to us. And we at our receivers through our antenna will receive this. Now, if they want to do a frequency modulation, means they will increase the frequency or decrease the frequency. This is known as frequency modulation. Both have their purposes, different purpose के लिए use करते हैं. We are not going into that कि when we will do frequency modulation or when we will do amplitude modulation. But the FM radio that you hear is a frequency modulated wave. So you have seen that FMs do not have huge ranges. You cannot hear the FM of that is broadcasted in Delhi, in Lucknow, or in Bihar, or the Chennai's FM will work only in Chennai. So FMs do not have high range. It has very small range. But AMs, जिसमें हम SW या MW दोनों short waves and medium waves are AMs. So AMs have very long ranges. Because it has been amplified, the signals will not be lost. they बहुत दूर तक travel कर सकते हैं. That's the purpose of amplifying. ठीक है? Amplified. So if you are in Chennai and you are able to hear something from Delhi, so probably you are on an amplitude modulated wave. So अगर तुम क्रिकेट कमेंट्री कभी सुन रहे हो रेडियो पे, so that means you are listening to amplitude modulation, either SW or MW. Now, going into a little bit deeper into this, how does this work? This is your Earth surface. Here you have your antenna. Now, radio waves travel into straight lines. So the antenna which is broadcasting this cannot, because of the curvature of the Earth, it has a range. It cannot broadcast beyond this limit. To broadcast beyond this limit, it has to increase its height. If it will increase its heights, it can go up to here or here. But because of its limit, it cannot broadcast more than a certain area, cover more than a certain area. इसको बोलते हैं surface broadcast, because the waves are traveling on the surface. There is also another kind of broadcast which is called as satellite broadcast. So satellite broadcasts can cover wide areas. And that's why nowadays we are moving to satellite broadcasts. If you have been reading the newspaper today, or I think it was in yesterday's news, DD is closing its radio stations, its antenna stations. DD क्या कर रहा है, ये वाला जो सिस्टम है ना, जब हम वो एंटीना छतरी लगा के और घुमा घुमा के न्यूज टीवी देखते थे, तुम लोगों ने पता नहीं एक्सपीरियंस भी क्या होगा या नहीं. So वो छतरी वाला सिस्टम जो है, now DD is saying कि now we will not provide that service, because this radio transmission, this surface transmission was costlier and now nobody is using this. Instead of that, DD is saying you set up a free of cost DTH, we will provide you signals from satellite. Yes, MW medium waves होता है दिव्या. क्या कह रहा हूं यहाँ पे, अभी DD पलक, मैंने क्या कहा कि DD अभी गवर्नमेंट ऑफ इंडिया ने अनाउंस किया कि ये वाला जो सिस्टम है, छतरी एंटीना लगा के टीवी देखने वाला, इसको गवर्नमेंट विल स्टॉप. नाउ दे विल प्रोवाइड डायरेक्ट सर्विस फ्रॉम सैटेलाइट्स एंड फॉर दैट यू हैव टू सेट अप DTH, डायरेक्ट टू एबल. वो छतरी आजकल जो लगा रहे हैं वो छतरी लगाना पड़ेगा. तो अभी तो ये तो टीवी के लिए कर रहे हैं, बट रेडियो इज स्टिल ब्रॉडकास्टेड थ्रू एंटीनास. ठीक है, रेडियो इज स्टिल ब्रॉडकास्टेड थ्रू एंटीनास, and that's why FM radios have very small antennas, and that's why they can cover only small range. But there is one more phenomena which happens in the atmosphere. This radio wave is transmitted. Now what happens? This, a part of this radio wave will also go into the air, or part which has gone to the earth that will radiate back to the air, reflect back to the air. Now in the air we have ionosphere. Ionosphere is in मेसोस्फीयर. तो वहां पे आयोनोस्फीयर है. ये आयोनोस्फीयर क्यों बोलते हैं इसको? बिकॉज हियर द सनलाइट्स which are coming, they will break the molecules into ions. तो क्या वो एक पूरा जो एटम था उसमें से उससे कुछ इलेक्ट्रॉन्स निकल के और फ्रीली एग्जिस्ट करेंगे, फ्री मूव करने लगेंगे, और वो पूरा एक चार्ज एनवायरनमेंट बन जाएगा. इट्स अ लेयर ऑफ चार्ज which has covered the earth. Ionosphere. Different ions are existing. Now, the composition of this ionosphere depends upon the sunlight, the day and the night. So in days, when more lights are coming, the composition will be different. We are not going to then again the details, बहुत detail है, but थोड़ा समझ लो. In sunlight, the composition will be different. In the night time, the composition will be different. The kind of ions which are present in the night time, they reflect the radio waves back to the earth. So now you can understand that I am sitting in Bihar and I can listen to a frequency broadcasted from Delhi in the night, because that has been reflected back by the ionosphere to the region where it was not supposed to go. समझ में आई बात? क्यों रात में तुमको क्लियर दिखाई दे रहा है या क्लियर सुनाई दे रहा है? Because the ionosphere is reflecting back, or reflecting back the waves back to the Earth's surface. It can cover more area and the signal will be also stronger. In the daytime, it will be observed by the ions and they will not reflect back. मजेदार नहीं लग रहा तुम लोगों को? लग रहा है समझ में आ रही बात है? इंटरेस्टिंग है. Pratham is saying, is there a drawback of security concern? There's no drawback of security drawback, but one problem is here, and you might have faced this. Now, when you have asked, again, it's kind of a tricky thing to explain, but let us try. See, हमने पहले ही देखा कि there are only certain kind of waves on which you can transfer the radio signals. And that's why you can understand कि why government auction spectrum. तुमने सुना होगा 2G waves, 3G waves, 4G waves, and now 5G waves, and government sell these spectrums. Government basically sell कि up this frequency, let's suppose government is saying कि 10 to the power 6 megahertz. Hertz is the unit of frequency. So ये वाली frequency Reliance को दे देते हैं. So now Reliance can use this frequency to send the data to its customers. Now government has monopoly over this. Now no other company can use this frequency. If other companies will start using the same frequency, there will be a class of data. Reliance भेजना चाह रहा है कुछ और कोई दूसरा भेज देगा कुछ और. To control that thing, government auctions these data by taking money. Now you can think of it as different kind of roads in the air. Some roads are very fast, high moving lanes. Some are slower, and government take different kind of tolls by different companies based upon what kind of speed they want and what kind of money they are taking from their customers. Now think about this situation. Again, these are the things whoever have ever operated a radio can easily understand. For others, it's a little bit difficult to understand. This is your radio. These are the two, let's suppose these are two countries. This is a signal in Nepal, and this is a radio station in Bihar. Now, Indian government has told that Patna radio station will send its signals at 10 to the power 6 megahertz की जो frequency की जो wave है, मान लो ये वाली जो road है, इस पे पटना station will broadcast its message, its programs. Nepal has also given the same frequency, 10 to the power 6 megahertz frequency, to one of its stations. Let's suppose they have given this to Kathmandu station. Now a person is sitting here at the border in India, at the border of Nepal and Bihar. When he tunes to 10 to the power 6 megahertz frequency, he is supposed to listen to the Patna news, because he thinks he is closer to Patna. There will be no problem in the daytime. He will listen to the Patna ka broadcast. But in the night time, the Kathmandu broadcast will go up and it will come down to this person as well. Now, when he will tune to this station, there will be a class. तो एक ही मीटर पे दो रेडियो स्टेशन सुनाई देते हैं. किसी ने एक सिचुएशन फील किया है कभी? Have you seen that on the same number, if you have ever dialed down your radio, on the same number you will listen to two conflicting radio channels operating. Oh, तुम लोग बहुत, चलो कुछ पुराने लोग हैं यहाँ पे. So thankfully you know this. So this kind of problem can happen, especially in the night time. Now last thing and then we will end this. बहुत ही मजेदार है. If you will go to the exosphere, it is very hot. Like it's super hot, sometimes thousands of degrees, 1000 degrees Celsius. But if you will put a thermometer here, your thermometer will not show any reading. It will not show you the temperature. But if you will go there, you will burn. राख हो जाओगे एकदम. But your thermometer, if the thermometer is able to sustain that heat, will not show any temperature rise or fall. And that's why I coined this term that exosphere is hot, but it has no feelings. You will not feel anything. You will directly burn. Exosphere is hot without feeling. Now, this is very interesting, huh? Hot without feeling. So let's come to the next class and we will discuss what is temperature and what is heat. And when we will understand the difference, we will able to understand why here you will not feel the heat, but you will burn. I don't know तुम लोग क्या फीलिंग आ रही है, मुझे बुद्ध जैसा फीलिंग आता है जब ये सब मैं पढ़ता हूँ। अच्छा इतना कुछ जानने को है। I hope you have the same feeling. You are feeling enlightened. You learned a lot. मिलते हैं फिर 3 बजे. We'll continue the discussion. 3 p.m. Thank you everyone. क्लास में आ जाया करो, मुझे भी थोड़ा वो मोटिवेशन रहता है पढ़ाने का, नहीं तो बाय.